Oh, hello, ladies and gentlemen. Hope you're all doing well today. Now, on Tuesday, I'm going to be out, so I am recording a description of some of the work pages we didn't get to the previous week, so everybody can have a chance to go over things. I'll annotate as we discuss. I do apologize, though I don't have a stylus, so I just have these like squared off hot dog fingers that I got to use to try and write on here. First thing we'll do, I think we all completed number one. I don't know exactly where classes left off. We'll look at number two. If we look at number two, first thing we'll notice is that the molecule is made of CHON, has carbon, hydrogen, oxygen, and nitrogen. It doesn't say anything about sulfur or phosphorus, so then we have to look for something else. Next thing I do is look for amino groups or carboxyl groups. So here, there's a carboxyl group. Here's an amino group. We've got an alpha carbon here. And then this is an R group. So we know the R group is what imparts some of the unique chemical properties of the amino acids. So we know we're looking at something in the protein category. And specifically, it's going to be an amino acid. Now, if we look at the R group, since it imparts chemical characteristics, we see that it's got nitrogen, so that's going to make it polar. And if it's polar and like dissolves like, it's going to be hydrophilic. So something polar and hydrophilic. All right. So that's number two. If we can move here, let's look at number three now. For number three, this one's sort of tricky. Again, we notice that it's made of CHON. So we've got carbon, hydrogen, oxygen, nitrogen. Next thing I do, again, I look for amine groups and carboxyl groups. So here's a carboxyl group on the end. Look on the other end. Here's an amino group. We got carboxyl, amino. So what we're looking at is a polypeptide. It looks like a chain of a few amino acids. So like here's an alpha carbon. There's a carboxyl group. Here, alpha carbon. So what we've got are a chain of amino acids. So this will go in the protein category, and it's a polypeptide. Now, in terms of the chemical characteristics, you'll notice here that this is a hydrocarbon. Again, each vertex is a carbon and associated hydrogen, so that would be a portion that's nonpolar. In this part, we'll see something that has oxygen, so that will be polar. So portions of the polypeptide will be polar or nonpolar. If they're polar, it'll be hydrophilic. Nonpolar, it'll be hydrophobic. Number four. Well, number four, we've got not chomp, but, well, I guess we could say chomp, because it mentions a base. You see your rings of carbon, so our carbon-based molecules. So that's your sugar. Then you see your phosphate group here. So we got a sugar phosphate backbone, and then they mention the bases. So there are your nitrogenous bases. So what we're looking at is a polynucleotide. So this is a chain of nucleotides. Okay, so we're dealing with nucleic acids. You got all these oxygens here, so it'll be hydrophilic and polar. With number five, what do we got? Oh, that's CHO. I'm not sure, a heck of a lot of O. So CHO and a lot of O. And another thing that you see with this is that it forms rings in solution. So if you see rings of carbon, hydrogen, oxygen, that's indicating that it's a carb. This looks like a disaccharide. It's two monomers linked together. Another thing about this, all the oxygen, it's going to make it able to dissolve in water. So it's going to be polar and hydrophilic. Let's see. Number six. It's CHO, and there's just a little bit of O at the end. Okay. So since it's CHO with just a little bit of O, this is a lipid. And as a lipid, being a hydrocarbon, it's going to be nonpolar and hydrophobic. It'll tend to avoid water. What you're actually looking at is one chain of a triglyceride. So remember, a triglyceride has a glycerol and 3 fatty acid tails. This is one of those fatty acid tails. So really good at storing energy. Number 7, if we look at number 7 here, there's a ring of nitrogen. Here's a phosphate group and a carb. So sugar, phosphate, nitrogenous base. You're looking at a single nucleotide. Okay, with all the oxygen and nitrogen, it's going to be polar and hydrophilic. So again, we're looking at one nucleotide, so that would go in the nucleic acid category. Let's see. Okay, this is sort of an interesting arrangement here. If we look at number 8, you'll notice it has CHON. Now, here's your amino group, or I'm sorry, there's your carboxyl group. Here is your amino group. So they sort of rearranged the model here. But there is the alpha carbon and its hydrogen buddy, and then this is your R group. Okay, so that is slightly different from this previous page where they had things listed out a little differently. Okay, so how things may be depicted may differ slightly, but just pay attention to those clues and you'll be in good shape. Now, if we're focusing on the R group to give it its characteristics, this amino acid, it's got some nitrogen in there, so it'll behave in a fashion that is polar and hydrophilic. All right, number 9. Oh my goodness. Lots of CHO, lots of O. This is a polysaccharide. So it looks like 4 monomers held together. So that's going to be a carbohydrate. It'll be polar and it'll be hydrophilic. And then 10 is a little tricky. 10, you see it's CHO, but it's got a fair amount of O, right? You have equal amounts of carbon and oxygen. So this is a carbohydrate, but rather than having it represented in a ring as it typically appears in water, this shows you a straight chain. So this would be like an anhydrous or a waterless version of the molecule. So again, it can be tricky because sometimes they'll represent carbs in a straight chain and other times they'll represent it in a ring. Here we go. So don't be fooled by that. Pay attention to the ratio of carbon to oxygen. Well, I think that takes care of this workbook page. If you have any questions, just shoot me an email. Let me know. Thanks a lot, guys.